Okay, let's talk about simultaneous linear equations. Now, simultaneous linear equations, it's to do with the fact that whenever you have a linear equation or you have a pair of them, if they're not parallel, at some point they'll cross somewhere on the Cartesian plane. Now, that part where they cross over the two linear equations is the solution of the pair of those. And so when we're talking about simultaneous linear equations, we're talking about trying to find that spot where they do cross over. Now, we're going to start off by looking at the graphical solution. Okay, so what we've been given, before I show the whole graph, is some linear equations. We're told that x plus 2y equals 4 and that y is equal to 2x minus 3. Okay, now you'll note that I have for each of these given them a little 1 in a square bracket and a 2 in a square bracket. I'm going to refer back to these 1s and 2s so that I don't have to rewrite this equation all the time. Okay, so I can see that with my two linear equations, I was also given a bit of a graph. Now, I don't know if those lines were exactly the same as those. In fact, I've been asked to check that. That's what we're trying to do. We're trying to prove that the solution is correct. Now, in this instance, we have the point of intersection right here. I'll put a big red dot on it. And the point of that intersection is x value 2 and a y value of 1. All right, so that means then that x is equal to 2 and y is equal to 1. So what we need to do is we need to take this point of intersection, plug it back into these functions, these linear equations, and see if the answers are correct. So this is the way that we do that. I'm going to leave that at the top of the screen there so that we've got our values of x and we have our value for y. So I'm going to check equation number 1 first, and this is this little square bracketed 1 so that I don't have to rewrite that there. Okay, what I will do is I'm going to check the two sides of that equation. That's what an equation is. It's two expressions with an equal sign in between. So I need to check for each of those expressions to make sure that they do equate. So here it is, my left-hand side. On my left-hand side, I have x plus 2y. I then substitute in my value for x and my value for y. So my value for x is 2, my value for y was 1. 2 times 1 will be just 2. So 2 plus 2 is 4. Okay, so that's what my left-hand side equals. My right-hand side, now the equation was x plus y equals 4, so it just equals 4. So what I say then, and this is the way that we actually write this, is that my left-hand side equals my right-hand side. I then have to go on and I will check it again for the second equation. So I will then check equation number 2, and I'll do the same thing. I will check the left-hand side. Now that equation was the 1 is equal to 2x minus 3. Okay, so I will then substitute in my values for x, which was 2, and y, which is just 1. And I have the left-hand side equaling 1, and once I've done the working out, my right-hand side equals 1. So again, I can say that the left-hand side equals the right-hand side. So what I need to do is I've proven that it is correct, so I will write that in both cases the left-hand side equals the right-hand side, therefore the solution of 2, 1 is correct. It's the correct solution for that pair of linear equations. Okay, so that's a graphical way. We can actually use the graph itself to find the point and be able to do that. Now, sometimes, and most of the times, if you're asked to solve simultaneous linear equations in a graphical method, you won't be given the graph to start with. What will happen is that you'll be given the two equations and you'll be asked to graph that. Okay, this is the quickest way to actually go about that. For equation 1, what we need to do is actually find the x-intercept. So now the x-intercept is when the y value is 0. So we take y is equal to 0 and plug that into the equation. We get x plus 0 equals 3, so x is 3, so the x-intercept is 3, 0. We then do the same thing for the y-intercept when x is 0. Plug that in, get our answer, and we write down what the y-intercept is. Once we've done that for equation 1, guess what? We get to do that for equation number 2. So, same process. X-intercept when y is 0. We'll work out our value for x, and then we know what our x-intercept is. Again, and you'll note that these can be kind of lengthy. Our y-intercept when x is 0. We plug in our value for x and work out what our value for y is, and we find out what our y-intercept is. Now for this next part, I have actually rewritten those. Normally you wouldn't rewrite those. Normally when you've written them once, that's enough. But I've rewritten them so that you can actually see them all together. Okay, so we've got my, for my first equation, I have my x-intercept and my y-intercept. Well, I'm missing a dotted I there. For my second equation, just here, I have my x-intercept and my y-intercept as well. I then would need to get some graph paper. I just happen to have some ready right here. My graph then is where I plot my points. So I will plot this first one probably in blue, why not? So my x-intercept is at 3, 0. So 3, 0 will be right here. So I'll put that in, 3, 0. I then also need my y-intercept, which is at 0, 3, which is all the way up there. And I'll put that in, 0, 3. And once I've plotted those 2 points, I need to use a straight line to join them up. There we go. There's my straight line that joins them up. Okay, now I need to do my second one. Okay, my second function. I have to plot that one. I'll do that in a different color. Okay, so I need my x-intercept, which is at 4, 0. Here it is here. So 4, 0. I'm pretty sure you can still see that. That's good. And my y-intercept is at 0, 2. So it'll be right here at 0, 2. And I need to then draw in that linear equation. There it is there. And I can see that they are crossing over at this point. Right, I'll try green, see if it turns up. It's crossing over right here at this point at 2, and the green's not a great color, but I'll use red. It is crossing over at 2, 1. So what I can say is that there is a solution right there at 2, 1 for these two lines. And I have done that and answered the question graphically. All right, so that's what it means to answer it graphically. Now, in every one of these, we should always check our work. So we know that the point of intersection was at 2, 1. So here's how you do your check. It'll look very similar to the check that we did in the first part of this particular video. I'm going to check for 1. I'm going to work out my left-hand side and my right-hand side for my values of x is equal to 2, y is equal to 1. Here's my left-hand side equals 3, the right-hand side equals 3. I will then also check my second equation. I can see that my left-hand side is equal to 8, my right-hand side is equal to 8. And then I can say in both of these equations, the left-hand side equals the right-hand side, therefore 2, 1 is the correct solution. Okay, so that's the process that you go through to be able to work out simultaneous linear equations using graphical means.